Okay, problem 44, page 657. Sister problem to 43. 43 is very similar to 44 here. Then we're taking on ellipses now, the second of the three conic sections that we're going to look at: parabolas, ellipses, and hyperbolas. And this is a nice, tame little problem that I think it's worthwhile doing these problems, kind of getting down what the standard form can tell you and how ellipses work. So the standard form for an ellipse is x minus h squared plus y minus k squared all over a squared plus b squared. It's equal to 1. And write in that fashion because hk is the center, 2a and 2b are the major axis and the minor axis. Okay, is that worth writing down? Maybe so. Maybe so. So the center is HK, the major axis, which in this case lies parallel to the x-axis, has a length of 2a. The minor axis, the major axis, maybe you want to call that the major diameter, but I am going to call it the major diameter. Maybe equals 2a, and the minor diameter, I'm not really sure if I like diameter, is 2b. Okay, so you can pull this off very quickly, and in fact, let's do that. If this is the general form and this is the problem we're working with, clearly h is equal to minus 4, k is equal to minus 2, and you know what? That's the center. So let me just, I want a pretty good size ellipse. Okay, so I'm going to just do this. I'm going to just draw some ellipse. I'm going to put some axes through it. What I've just told you is that this dimension right here is 2a. Okay, and in our case, if a squared is 9, then a is 2, and 2a is 6. Okay. And here is the minor diameter coming at you right here. Let's do it like that. Erase that and say that 2b, if 2b is, if b is 4, if b squared is 4, b is 2, 2b is 4. I'm not sure I did that right. B squared is 4, b is 2, 2b is 4. Okay, so there we've got my funky looking ellipse, and at this point, that center point is, as we said, minus 4, minus 2. So there's a, there's a coordinate system and an origin 0, 0 someplace over here. The ellipse is 4 over and 2 down. So what do we have to do next? We have to find the vertices, and we have enough information here on the page to allow us to do that real quick, because this major diameter is 6 long, so it goes 3 this way, 3 this way. So this point right here has the same y coordinate as the center, minus 2, but it's 3 over from here. Okay, so this is the point minus 1, minus 2. Right, I've added 3 to that, and likewise, this is the point, same y coordinate, but it's 3 over from minus 4, so this is minus 7, minus 2. We can do the same thing up and down. This has the same x coordinate as the center, but it is, what did we say, 2? We said a is equal to 2 someplace. I wish I had done that. I didn't. Here, a is equal to 3, b is equal to 2. So a is equal to 3, that's why we went 3 over and 3 over. B is equal to 2, so we got to go 2 down from here, that's minus 4. And we got to go 2 up from here, well, bless our hearts, that's 0. Minus 4 is 0. So there's the answer to the vertices. Again, the center is minus 4, minus 2. The vertices are, I'm going to go around the horn here, minus 7, minus 2, minus 4, 0, over to here, -1, -2, and one more, -4, -4, okay? And we're left now with finding the focal points, and here's one of them, and here's another one of them, and here's what we might do. I might erase this center. If we just gotta have it, we're gonna put it right there. I want to erase it because I want to draw these two little lines, and in fact then I want to draw these two little triangles. Okay, let's see what we know about these triangles. The distance from the center to the focal point is called the focal length, and it's usually given the designation C. Okay, this distance up from the center to this vertex is B, and what the heck is this? What is x? Okay, well, it's c squared plus b squared, because it's the x squared is c squared plus b squared. But more importantly, remember that every point on an ellipse, what this one, yeah, that one, has the property that the sum of its distance from here to here is the same as those distances for any other point. How about this one? Yeah, that distance plus that distance is the same as that distance plus that distance is the same as this distance plus this distance, and we call that distance 2a. Okay? Let me erase that for a second to get some room. So, so this distance plus this distance is 2a. By symmetry, you can see, and we called it x, you can see that they're both the same, so you can see that x is equal to a. All right, and you've got this little triangle, all ellipses in this orientation, actually all ellipses have this same relationship. So you can see that, what are we looking for? Well, let's just say that a squared is equal to b squared plus c squared. Let's put some numbers in and find this c, the focal length. A is 3, so this is 9. I'm going to put the b over here, and b squared is 4. That's equal to c squared, so that's 5, and that makes c equal to root 5. I can find the focal points now at this point, because this focal point is root 5 removed from this point. It has exactly the same y coordinate, but it's the -4 is moved over by root 5, so that point is root 5 minus 4. There's the x coordinate, there's the y coordinate. I'm going to put that right here. Root 5 minus 4 minus 2, and do the same thing over here. Same y coordinate as the center, but moved over to the left by root 5. So that's minus root 5 plus 4 minus 2. Okay, so a little bit of a nightmare and a mess here, but there's the data that was asked for based on that form.